Dear students, today I'll discuss with you some important MCQ from the chapter Chemical Equilibrium. First question, in the study of the reaction A plus B reversible C plus D, A and B mixed in a vessel kept at T Kelvin, the initial concentration of A was twice the initial concentration of B. After the equilibrium reached, the equilibrium concentration of C was 3 times the equilibrium concentration of B. Calculate K equilibrium. Okay, so these are the options given. Okay, so I already solved this problem. So see, this is A plus B reversible C plus D, that initially B is X and A is 2X because it is given in the question. So at equilibrium, alpha amount changed to C and D. So remaining is 2x minus alpha, x minus alpha. So equilibrium concentration of A, 2x minus alpha by 1 volume. B is x minus alpha by 1 volume. Concentration C, alpha by 1 volume. D is alpha by 1 volume. So Kc, equilibrium constant, is C concentration, D concentration by A concentration multiplied B concentration. So putting all the concentrations here, and in the next it was given the equivalent concentration of C was 3 times the equivalent concentration of B. So according to this, it is 3x minus 3 alpha. 3x minus 3 alpha is equal to alpha. So alpha you find 3 by 4x. Okay, putting this value in this above, so you will get this. Okay, so solving this you will get 9 by 5, that is 1 plus 1 point D. So choice A is the correct answer. Okay, next question. An equilibrium mixture for the reaction 2H2S giving reversible 2H2 plus SO2 had 1 mole of H2S, 0.2 mole of H2 and 0.8 mole of S2 in 2 liter vessel. The value of Kc is what? So these are the options given. This is also I solved. So see question 2, 2H2S reversible 2H2 plus S2, all are in gaseous state. Concentration of H2S half, 0.5 mole. Concentration of H2 0.2 by 2, this is 0.1. Concentration of S2 0.8 by 2. Okay, this is 0.4. So putting all the concentration here, you will get this, and solving you will get 0.016. So choice C is the correct answer. Okay, next question. A vessel of 1000 K, a vessel at 1000 K contains carbon dioxide with a pressure of 0.5 atmosphere. Some of the CO2 is converted into carbon monoxide on the addition of graphite. The value of K if the total pressure at equilibrium is 0.8 atmosphere is what? So these are the options given. Okay, so it is also solved, and I will explain this. See, CO2, and this is graphite in the solid state, and this is carbon monoxide, this is the gaseous state. So this is 0.5 mole and this is 0 initially. Atmosphere changes x, this is 2x. So at equilibrium the remaining is 0.5 minus x, and this is 2x. So total pressure is 0.8, it is given. So according to this, 0.5 plus x, okay, is equal to 0.8. So x is equal to 0.3. So equilibrium 0.5 minus 0.3, okay, and this is 2 multiplied given. So 2 multiplied 0.3. So here remaining is 0.2, 0.5 minus 0.3, remaining is 0.2, and this is 0.6. So Kp is equal to 0.6 multiplied 0.6 divided 0.2. So it is 1.8 atmosphere. So choice 3, B is the correct answer. Okay, next question. Consider the following equilibrium in a closed container N2 for giving 2NO2 gas at a fixed temperature. The volume of the reaction container is halved For this change, which of the following statements hold true regarding the equilibrium constant Kp and degree of dissociation? So these are the choices given. A. Neither Kp nor alpha changes, both Kp and alpha changes, Kp changes but alpha does not change, and choice D. Kp does not change but alpha changes. It is also I solved. You see what is happening. Kp, see, Kp is constant at constant temperature. As volume is halved, Boyle's law, at volume is halved, pressure will be doubled. Hence, equilibrium will shift backward direction, that is degree of dissociation decreases. So choice D is the correct answer. Next question. Question number 5. Which of the following is true for diprotic acid? Diprotic acid means giving 2 H plus ions. Okay, you see, this is when it is diprotic acid. What happens for any polyprotic acid? The first constant will be always be greater than rest, as after losing one proton, it becomes difficult to lose another electron and acts as a acid. Okay, how this is? So you see, H2S, suppose this is diprotic acid, so giving H plus plus HS minus. Okay, so after giving this H plus, here it is difficult to give another H plus. So HS giving, it is difficult to give another H plus. Okay, this is the case. So choice B is the correct answer. Next, question number 6. The reaction quotient Q for the reaction nitrogen and hydrogen giving 2 ammonia is given by Q is equal to NH3 power 2 nitrogen hydrogen power 3. The reaction will proceed from right to left if what is the condition? These are the choices given. You see, reaction quotient, question number 6, reaction quotient Q, C and equilibrium concentration. Equilibrium constant is always taken as at equilibrium, but reaction quotient at any instant, the ratio, let us say it is A plus B giving C plus D. So at any instant, if QC is calculated, C concentration, D concentration, A concentration, B concentration. But what is QC? QC at only equilibrium. At equilibrium, Kc is equal to C concentration, D concentration by A concentration, B concentration. Okay, so this is the case. So far, question number 6. You see, example is taken. Let the equilibrium concentration of nitrogen is this much, equilibrium concentration of hydrogen is this much, ammonia is this much. So Kc is this much. But Qc is calculated at any instant, at any time. So let its concentration this much. So this is the case. So question choice B is the correct answer, because Q is less than Kc, or Kc is greater than Qc. Okay. Next, the equilibrium constant for the reaction nitrogen oxygen giving 2NO at temperature T is this much. The value of Kc for the reaction NO giving half N2 plus half O2 at the same temperature what? Okay, so this is the same case. Already in any last video I explained this. You see, for this equation you find out the Kc. So Kc is this much is given. Okay, so you see this is the square. Okay, so removing the square root. Okay, so you remove the square root, you will get what? NO, N2 half power, O2 half power. This is the case. Okay, and this is the value, and you take the root over, you will get 2 multiplied 10 to minus 2. Okay, but for this reaction it is reverse. For this 2NO is the product side, for this NO is the left hand side. So you take 1 divided 2 multiplied 10 to minus 2 is the answer. So you will get 0.5 multiplied 10 to 2, that is 50. So choice B is the correct answer. Okay students, next question last. For the reaction 2NO2 giving 2NO plus O2, Kc is given, equilibrium constant is given at 184 degree centigrade. So our inverse this to 0.0831. okay, and when Kp and Kc are compared at 184 degree, it is found that what you see. So the relation is Kp is equal to Kc power RT delta N. So here this side 3 moles are there, this side 1 mole is, so delta N is 1. So Kp, Kc, put the value R is given, T is this much Kelvin. So Kp is equal to, this is Kc 0.00831 multiplied 457. okay, so put, you will get this much. So this is what, this is greater than 1.8, this is the value of Kc. So Kp is greater than Kfc. So choice A is the correct answer. Okay students, have a good day.